A closed heat exchanger has a hot line and a cold line with known inlet and outlet states. The mass of the cold line is also known. What is the heat exchanged? In Thermonator, we set up a control volume exercise, since the heat exchanger is an open system. We also set power units, because mass has units of time. First, we enter the pressure and temperature data for inlet 1, and click the Calculator button to obtain the state using these values. Within a heat exchanger, all processes are isobaric, since the substance exerts the same pressure at the inlet and outlet. For this reason, we select the Isobaric menu and click on State 1 to create the first process. We enter the vapor quality of outlet 2, and click the Calculator button to obtain the state with that vapor quality and pressure for the isobaric process. We click on the graph to create the other isobaric process. We define the process mass as 9 kilograms per second by clicking the Calculator button. We enter the pressure and temperature data for inlet 3, and click the Calculator button to obtain the state using those values. We enter the temperature for outlet 4, and click the Calculator button to obtain the state at that temperature and pressure for the isobaric process. We select the Heat Exchangers menu to adjust the energy exchange between the two processes. We select the Closed, 2 inlets, heat exchanger. We select process 3, 4 as the cold line. We solve for the mass of process 1, 2, using the energy balance equation, as it is the only unknown in the equation. We see that, although the heat exchanger does not exchange energy with its surroundings, the internal processes exchange 5,266 kilowatts of energy. In the main window, we see that the solution to the problem is 5,266 kilowatts of heat. In summary, the processes exchange energy in the form of heat. This energy is stored in the substance as enthalpy, since the processes do not perform or produce any work. If you like this exercise, give it a like and share it with your friends.